Hello. In this video, I discuss about the main idea of federated reinforcement learning. I assume you are familiar with federated learning and reinforcement learning. My name is Yusuf, and I am going to present this video. Here you see the list of the outline. We discussed about federated reinforcement learning, federated deep Q learning, horizontal approach, provide example. Vertical approach, we compare horizontal and vertical. And finally, present reference. Okay, federated reinforcement learning allow multiple agents to collaboratively learn an optimal policy without sharing raw data. Okay, we have multiple agents collaborate with each other to learn an optimal policy without sharing their relevant data. This improves the privacy and security. Agent can learn from diverse environment and improve the overall policy. Okay, federated reinforcement learning allow agents to share experience with each other and learn from diverse environment and improve the overall policy. Okay, in this slide, I discussed about federated deep Q learning. Overall, we have four main steps: initialization, local training, aggregation, and global model update. We have multiple agents. Assume we have multiple UAV that are uh, in communication with the ground control station. Okay, each UAV is initialize a local queue network, and the server ground control station is initializing global queue network. Each UAV collect experience and update the queue network using the DQN algorithm. Okay, and then each UAV send the weight of the queue network to the ground control station. Ground control station average this weight and send back the average value to each UAV, and this process is repeated. Okay, this scenario enable UAV to share the experience with each other and learn optimal policy in a collaborative way. The most important advantage of this approach is improving security and privacy. Also, it has some benefit for the learning capability, improving learning efficiency, achieving faster convergence, and also enable them to share experience together. Okay. Okay, in this we have two main paradigms for federated reinforcement learning: horizontal federated reinforcement learning and vertical federated reinforcement learning. You can see we have different agents working in different environment. Okay, the point is that the structure of the state and action space in horizontal federated reinforcement learning is similar for all of the agent. Okay, the feature set of the state and action space is similar for all of the agent, but each agent is acting in a different environment. Okay, this is horizontal federated reinforcement learning. The feature set for a state space and action space is similar for all of the agents, but agents are acting in different environment. Okay, let me share with you a typical example. Imagine we have 10 autonomous vehicles driving in different city or in a different country. Okay, uh, federated reinforcement learning enable these autonomous vehicles to share their experience with each other. Okay, enable them to share their experience with each other. In this case, even if other vehicle never encountered a situation, suppose 9 vehicle out of 10 vehicle never encountered a situation, they can still perform the best action by using the shared model. Okay, one vehicle have experience through federated reinforcement learning, share this experience with other nine vehicles, and other vehicle even they have never encountered a situation, they can make informed decision. This is the main idea of the horizontal federated reinforcement learning that enable autonomous vehicle to share their experience with each other and enable all of them to make informed decision. Okay, here you see the structure of the vertical federated reinforcement learning. In this scenario, agents are acting in one environment, but they have different state and action space. Okay, agents are acting in different sorry, agents are acting in one environment, but they have different feature set for a state and action space. In the horizontal federated reinforcement learning, the feature set for a state and action space was similar, but in vertical federated reinforcement learning, the feature set for action space and state space is different. Okay, as you can see also in this figure, we have different agents. They have a different state space and different action space. Okay, in this table, we compare horizontal and vertical approach uh, from data characteristic point of view. In horizontal federated reinforcement learning, agents have the same type of data, the same feature set. The feature set of the state and action space is similar, but in vertical federated reinforcement learning, they have different feature sets. The feature set of the state and action space are different. Okay, from point of the environment, for horizontal federated reinforcement learning, agents operate in different environment or region. For example, that autonomous vehicle example that I provided. But for vertical federated reinforcement learning, agents operate in the same environment but observe different aspects of it. Okay, agents operate in the same environment but observe different aspects of it. Okay, but from collaboration type point of view, in horizontal approach, model updates are aggregated from agent with similar tasks, and for in vertical approach, model update from different feature space are aggregated. We told that we have different feature space in vertical approach, and model update from different feature space are aggregated. Okay, and as the example of horizontal approach, drawn in different region, each learning from similar sensor data. Imagine we have a multi UAV system. Each UAV is acting in different region, but they are learning from similar sensor data. And for vertical approach, autonomous vehicle, example of autonomous vehicle, each with different sensor. Okay. This is the reference of my presentation, Federated Reinforcement Learning Technique, Application, and Open Challenge. This is a good paper. I recommend you to have a look in this paper. Okay. Thank you. If you learned something from this presentation, I appreciate to like and subscribe.